Hello class, this is Mrs. Zappia with Lesson 8, representing proportional relationships with equations. Our essential question for Lesson 8, how can unit rate be used to write an equation relating two variables that are proportional? In example 1, do we have enough gas to make it to the gas station? Your mother has accelerated onto the interstate, beginning a long road trip, and you notice that the low fuel light is on, indicating that there is half a gallon left in the gas tank. The nearest gas station is 26 miles away. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. And remember, you have half a gallon left. So looking at the table, gallons is the X variable, and gallons is independent because you determine how much gas you put in your tank. The miles driven is the Y value, and that is the dependent variable, because miles driven is dependent on the amount of gas you have. Find the constant of proportionality and explain what it represents in this situation. Remember that the constant of proportionality is also called the unit rate. And that is found by dividing y by x. And remember that the x value is what you want one of. And we want to know how many miles you can drive on 1 gallon. So the y value is the miles, and the x value is the gallons. So we'll take our ordered pair, 224 divided by 8, and that is going to give us the value of k. 224 divided by 8. And that amount is 28. So k is equal to 28, and that is our constant of proportionality, or our unit rate. And you would find that if you divided 280 by 10, or 112 divided by 4, that you would get 28 for all of those. And that's because it is a proportional relationship. So what this 28 means is that you would get 28 miles on 1 gallon of gas. Next, write an equation that will relate the miles driven to the number of gallons of gas. So the structure of our equation for a proportional relationship is y equals kx. And once you have determined what the constant of proportionality is, you just substitute it for k. So the equation is y equals 28x, where y is the miles driven and x is the gallons of gas. And k is 28, because you can get 28 miles for 1 gallon of gas. This is important because you can use this equation to answer questions about how many miles you can drive based on how many gallons of gas you have. Knowing that there is a half gallon left in the gas tank when the light comes on, will she make it to the nearest gas station? Explain why or why not. Now we know that the gas station is 26 miles away and that she have a half gallon of gas left. So we want to know how far will that half gallon take her. So remember that x is our gallons of gas, and we know that we have a half a gallon. So we'll use the equation y equals 28, and we'll substitute x for the half gallon. And remember that when you have two numbers next to each other with parentheses, that indicates multiplication. So we want 28 times half, and half of 28 is 14. So solving our equation, y equals 14. Now remember that y is the miles, and that means if you have a half a gallon of gas, you can drive 14 miles. So she does not have enough gas to get to the gas station. It is farther than 14 miles. Using this equation, how far your mother can travel on 18 gallons of gas. Solve the problems in two ways, once using the constant of proportionality and once using the equation. Using the constant of proportionality, we know that she is going to get 28 miles to the gallon, and she has 18 gallons. So 18 gallons times 28 miles per gallon is going to equal the total, which is 504. And that's 504 miles. And the 28 is the constant of proportionality. Using the equation from the previous example, or the first part of the problem, was y equals 28x, where y is the number of miles, 28 miles per gallon, and we have 18 gallons of gas. So you see the similarity between the problems. And then you just multiply 28 times 18, and you see that you get the same answer. So here they're just teaching you how to use the equation to solve the problem. In the next problem, use the constant of proportionality and then the equation. Determine how many gallons of gas you would need to travel 750 miles. So you'll notice that this time the information is given to you is how many miles you're driving, and you need to know how many gallons of gas you have. So let's use our equation first. We have y equals 28x, where y is the number of miles. And we know the number of miles is 750. We know that we get 28 miles per gallon, and we need to solve for x to determine how many gallons that will require. So this 28 times x, what we need to do to solve for this is to actually divide by 28. And when you're solving an equation, remember that you have to do the same thing with the same number on both sides of the equation. So we do 28 divided by 28 is 1, and 1 times x is x, and 750 divided by 28 is the solution to the problem, which is 26.8. And that means that the number of gallons required for this trip is 26.8 gallons. Solving it using the constant of proportionality just means solving the problem without writing the equation. So we have 750 miles divided by 28 miles per gallon, and when you do that division, you get the answer, 26.8 gallons. Again, just to review, the x variable is the independent variable on the horizontal axis. That's what you want one of, 1 gallon. And the vertical axis is the dependent variable, which is the y value. So the y value in this case was the miles, and the miles traveled is dependent on how much gas you have. And the gas is the independent variable because you determine how much gas you have in your tank. In the next example, Andrea is a street artist in New Orleans. She draws caricatures, which are cartoon-like portraits of tourists. People have their portrait drawn and then come back later to pick it up from her. This graph shows the relationship between the number of portraits she draws and the amount of time in hours she needed to draw the portraits. So the independent variable is the x value, and that is the time spent drawing the portraits. And the dependent variable is y, the number of portraits that she can draw. So how many portraits she can draw depends on how much time she puts in working on the pictures. The first question says, write several ordered pairs from the graph and explain what each ordered pair means in the context of the graph. So we want to look at the line on the graph, and you want to see where this line intersects the vertical and the horizontal lines. So this point right here would be 1 hour, but it's hard to determine how many portraits it is. So you want to look for where the line intersects the vertical and the horizontal number. So right there we have 2 drawings taking, well, wait, that's time. We have 2 hours taking the time for 3 pictures. So that's one of our ordered pairs right there. And then our next ordered pair, so 3 hours, that's hard to determine, so let's keep going. And right here, that's a good intersection, and that tells us that it was 6 portraits drawn in 4 hours. And our third ordered pair, let's see, 4 here, and let's keep going to find a point of intersection. And again, the point of intersection, you're looking for where the x and the y values cross. So there are our 3 ordered pairs. Let's write those down. And remember when you're writing ordered pairs that they are in the form of x and y. And yes, order matters. The x value always goes first. So our first ordered pair is 2, 3. And you always want to include parentheses around your ordered pairs so that you know that it is an ordered pair and not just 2 random numbers. Our next ordered pair is 4 and 6. And our last ordered pair is 6, 9. And explain the context of this graph. So what that 2 means, the 2 is the number of hours, and the 3 is the number of portraits. Write several equations that would relate the number of portraits drawn to the time spent drawing the portraits. So remember to write the equation that you have to first figure out what k is, and then you put it in the equation y equals kx. To determine what k is, you use y divided by x. So let's take our first ordered pair of 2 and 3. And remember that 3 is the y value over 2. And 3 divided by 2 is 1.5. So k equals 1.5. Let's use 1.5. Then we write it in the equation y equals 1.5x. Then it says write several. So let's do it with the next ordered pair. K equals y divided by x. And in this case, the value of y is 6. So we have 6 divided by 4. And go ahead and calculate 6 divided by 4. And you'll see that k equals 1.5. So y equals 1.5x. And with our last ordered pair, remember that that is our y value. The unit rate is y divided by x. So we have 9 divided by 6, and k equals 1.5. Now you might be thinking, why is the unit rate the same for all of them? Well, she is working at the same rate. She is not drawing faster or slower. So that time is proportional to the number of portraits that she is drawing. And so our equation again is y equals 1.5x. You get the same equation because it is a proportional relationship. And that proves that you can use any of the ordered pairs to find that unit rate to write the equation. So it says determine the constant of proportionality and explain what it means in this situation. Well, we've already determined the constant of proportionality, but let's write it again so that you know what it is. The constant of proportionality is 1.5. And what it means in this case so we were determining what 1.5 means in this situation. And remember that k is equal to y over x, and that is the amount for one of the denominator. And x represented in this case, let's look at our numbered pairs again. X represented the number of hours. So we have hours in the denominator, and we have portraits in the numerator. And so that represents how many portraits can be drawn in 1 hour. Keep in mind the purpose of writing the equations. There are two things that you can do once you've got your equation. You can use this equation to find the number of portraits, and that would be 1.5 times the number of hours worked. You could also use it to find the number of hours worked by taking the portraits drawn and dividing by 1.5. Tomorrow we'll answer the essential question in the summary. Let's continue to the next page. In Lesson 8, you learned how to write an equation for a proportional relationship between x and y, where k is the constant of proportionality. The constant of proportionality is also called the constant or the unit rate. The constant of proportionality is the multiplier between each x value and its corresponding y value. We are combining Lesson 8 and 9, so next we will build on the concept of writing an equation to express the proportional relationship, practice determining which values are x and y, and use the equation to solve problems. In Lesson 9, our essential question is, what is the structure of a proportional relationship equation? In example 1, Jackson and his grandfather constructed a model for a birdhouse. Many of the neighbors offered to buy the birdhouses. Jackson decided that building birdhouses could help him earn money for his summer camp, but he is not sure how long it will take him to finish all of the requests for the birdhouses. If Jackson can build 7 birdhouses in 5 hours, write an equation that will allow Jackson to calculate the time it will take him to build any number of birdhouses, assuming he works at a constant rate. So write an equation to find out how long it will take him to build any number of birdhouses. Well, first you have to know how long it takes to build one birdhouse. So we want to know, do we want to determine how much time it takes to build one house? Or do we want to know how many houses are built in 1 hour? Because that determines in what order you divide the two values. In this case, we want to know how long it will take him to build any number of birdhouses. So we want to know how long it will take to build one birdhouse. So 1 will be our denominator. So remember that we start out finding what k is, and to find k, we do y divided by x, where x is what you want one of. And we want to know how long it takes to build one birdhouse. So we are going to use the division time divided by house, where y is the number of houses and x is the number of hours. Oh, sorry, that's the other way around. Let's fix that. Again, we want to know how long it takes to build one birdhouse. So we have one house on the bottom, and we have the time on the top. So our time is our y value, and our houses are our x value, and that will equal k. So we know that to build 7 birdhouses, it takes 5 hours. And then we do 5 divided by 7, and we round that to the 10th place. 5 divided by 7 equals 0.7. So we want to write our equation. Remember, you start with the structure of y equals kx, and then you substitute k. So our equation is y equals 0.7x. Then our equation, how many birdhouses can Jackson build in 40 hours? So we need to know, was y the hours or is x the hours? So look back, and we see that the time is the y value, so 40 hours is the time. So we'll substitute y. We get 40 equals 0.7x. And we need to determine 7 times what number is going to equal 40. To solve that equation, we're going to divide by 0.7. you have to do the same operation with the same number on both sides of the equal sign. So we're going to divide both sides by 0.7. A number divided by itself is 1. 1 times x is x. And 40 divided by 0.7 is 57.1. So we have a value for x, and remember that x is the number of houses. So in 40 hours, Jackson can build 57.1 houses. Next, how long will it take Jackson to build 35 birdhouses? Use the equation. So notice that in the previous problem we had 40 hours and we had to determine the number of houses. In this question, we know the number of houses and we want to determine how long it will take. So we use the same equation. We had y equals 0.7x, and remember, what does y and x stand for? X stands for the number of houses, and y stands for the time. So we have, get rid of that. We have 35 birdhouses. I can't seem to get rid of that. Birdhouses. So we're going to substitute x for 35 and bring down the rest of the problem. 0.7 times 35 is going to equal y, which is the amount of time it takes. So here we multiply 0.7 times 35 to solve our problem. And that answer is, multiplying 0.7 times 35, we find that the answer is 24.5. So y is equal to 24.5. And interpreting that answer, the 35 houses will take 24.5 hours to build. 24.5 hours. And we know these are correct by looking back at the original proportion that they gave us. They said that 7 birdhouses take 5 hours, and then we calculated for 40 hours that it would take 57.1 birdhouses, and in this problem that it would take 24.5 hours to build 35 birdhouses. So if you did the division, 5 divided by 7, 40 divided by 57.1, or 24.5 divided by 35, you would get the unit rate, which is 0.7. Now, it's not going to be exact because we rounded these numbers, but it will be approximately 7.7. Next, pause the video and solve this problem. How long does it take to build 71 birdhouses? Use the equation to solve the problem. Check your solution. Here's your equation. Substitute the numbers, multiply to solve the problem, and the answer is 49.7 hours, which is 49 hours and 42 minutes to build 71 birdhouses. And you can either answer with a decimal, or you can convert the 0.7 to minutes and answer as 49 hours, 42 minutes. And again, to do that conversion, that would be 0.7 times 60 minutes per hour, and that's where the 42 minutes came from. In our last example, Al's produce stand. Al's produce stand sells 6 ears of corn for $1.50. Barbara's produce stand sells 13 ears of corn for $3.12. Write 2 equations, one for each produce stand, that models this relationship. So we see in Al's produce stand that we're paying $1.50 for 6 ears of corn. Remember that in order to write an equation, you need to determine the unit rate. So you want to think about this. Do you want to know how much 1 ear of corn costs, or do you want to know how much corn you can get for $1? Remember, what you want one of is your x value. So when you're determining the unit rate, remember to take the cost and divide it by the number of ears. And that's going to give you the cost for 1 ear of corn. So here, ears is the x value and y is the cost. So remember that the unit rate is determined by y divided by x, where x is what you want one of. And we want to know how much 1 ear of corn costs. So we take an ordered pair, and we take $1.50 and we divide it by 6 ears of corn. So the unit rate at Al's produce stand is 25 cents, 0.25. And that means that 1 ear costs 25 cents. Now it says to write an equation. So remember that the structure of the equation is y equals kx. We found the unit rate, and now we substitute it for k. So y equals 0.25x. And that is the equation that can be used to determine how many ears of corn you can buy for a certain amount of money, or if you know how many ears of corn you're going to buy, how much money it will cost. So now let's do that for Barbara's produce stand. I'd like you to try that. Please pause the video and then check your work. The equation for Barbara's produce stand is y equals 0.24x, where x is the number of ears purchased and y is the total cost. We'll fill in the summary tomorrow during class. Let's review what we've learned in this lesson. In Lesson 9, you learned that a proportional relationship can be expressed in an equation in the form of y equals kx. K is the constant of proportionality, also called the unit rate. To find the constant of proportionality, k is equal to y divided by x, where x is what you want one of. This is important because the equation can then be used to answer questions about the quantities, such as, how much will 5 ears of corn cost? Or, if I spend $10.50, how many ears of corn will that buy? That's a wrap for Lesson 8 and 9.